Good evening, everyone, and welcome to the Rancho Mirage Library and Observatory. My name is Eric McLaughlin. I am the astronomer here, and what we're hoping to do tonight is we're hoping to take a look up at a nice waxing crescent moon. Now, I will note, as we're getting started, a special thank you to the Rancho Mirage Library and Observatory Foundation. It is through the foundation that we're actually able to offer events like these, so special thank you to them, and thank you to all of you for being here tonight. Now, as we're getting going here, I got something to point out, and that is those clouds you're seeing over on the left side of the screen. All of these clouds happen to be rather frustrating for us for a number of reasons. For one thing, it looked like they would likely blow out of the way. As you can see, we were quite thin at this point in the day, but then they got quite thick as the sun started going down. We do hope that they will actually move out of the way. I can see gaps in the clouds where we hope the moon will poke through, but we'll go ahead and see there in a second. I just see now that my computer is not connecting to chat, so if you're saying something, I want to make sure I can hear that, so let me take a look at that. Just a moment while I try and find out what it is you might be saying. There we are, found a way to actually catch the chat. Not sure why I couldn't actually see it there. Alright, welcome everyone. Glad you guys can make it here. Now, while we're waiting for the sky to give us a nice opening, there's a few things we can actually go into, including seeing what our ideal sky might actually look like. Our ideal sky would look rather different, because our ideal sky would have looked a bit more like this from here, where we actually have a good, very clear and in this particular view, this is a view of what we would see if we were looking up at the sky from the observatory if there were no clouds. In this view, you can see the moon quite readily. It's located quite high in our sky at the moment, right in the constellation of Leo. But as is evident here, we are still going through a lot of twilight, so stars aren't really going to be visible even if these clouds weren't here right now. We'll give it some time, and again, hopefully we'll get a nice gap in the clouds as things go along there. What we're at now is, again, what is called a waning crescent phase, which is different than all of the other Swoon at the Moon events we've done in the past. We have always focused on first quarter moon because, well, for live events, not everyone can necessarily make it here, and it's also not recorded for later. So as these end up being recorded for later, we decided we would start wandering through the phases for everyone so they can see a few other things going on. So a waxing crescent phase simply means that the moon is getting more and more full, and it's currently at a point where it looks like a nice crescent, which looks a bit like this. Now, this particular view is a great one. It's again from NASA's Science Visualization Service, and you can see a lot of good data here, including the exact line we expect to see where the terminator is. The terminator is, once again, the dividing line between the day side and the night side of the moon. Now, those of you who are in other parts of the country probably have either a really good view, or it could also be cloudy there, or it might actually have already set depending on where you happen to be, because as it is a waxing crescent moon, it is worth understanding when you get to see it. A waxing crescent moon always is visible not long after sunset, and you can get a feel for that by looking at this diagram up here. This diagram up here shows the Earth in the center with the day side of the Earth currently facing towards the top of the screen, and as you can see, the moon is not yet at the point of being overhead, or over in some sense the point of sunset, this point right here. So we see the moon as less than half full because of that. Now, how do the phases actually work? Well, let's take a look at a nice little video to help describe that. Now, this particular view is that same diagram up in the corner, but it is actually watching the Earth-Moon system, not to scale, over the course of a full year. So as time goes on in this movie, the direction towards the sun will slowly shift around, and the moon will be constantly orbiting around the Earth. And it is worth noting one particular little detail that I'll come back to after we're talking a bit about the phases, and that is that the phase cycle for the moon, the amount of time it takes for the moon to go through all its phases, is different than the length of the moon's orbit around the Earth. They're different by a couple of days, actually. 27.3 days for the full orbit around the Earth, while 29.5 days for the full set of phases. Why is that? Well, because we're orbiting around the sun, and this diagram shows that the illuminated side of this diagram shifts slowly. And as it's set up here, this the sun being off to the right in this image is right around the spring equinox, which means right now, as we just passed the northern hemisphere's summer solstice, the sunlight will be coming from directly overhead. Now, as things are going on here, you can actually look and figure out what time everything is on the Earth, because again, you have sunset over here, you have sunrise over here, so noon would be right along this vector roughly, while midnight would be along this vector, halfway through the night, literally midnight. And so where you see certain phases corresponds to the position of the moon relative to the Earth, and what time you see the phases depends on that same positioning. So again, right at sunset, you have first quarter phase over here where the moon just passed straight out over sunset, and that's when it's half full, whereas third quarter comes right overhead, right at sunrise, as it was shown there. And the new moon, when the moon is completely dark to us, occurs when it's right over or up in the sky at its highest point around noon. Can also get your full moon is going to be at its highest point in the sky at midnight. So comparing the portions that you'd expect to see visible from the Earth, looking out here you would see the crescent, here you would see half full, here you would see what is called waxing gibbous, and then you'd head towards full right about here, and then you'd end up with a waning gibbous. You'd start to see a little bit of shadow there, and then you'd get third quarter, and then you get your waning crescent, and back to new moon right about there. So that is your rough blitz through the phases. And so what we want to do over the course of the next few months is we want to actually work through a bunch of these phases, just walk through them, and that will work by actually having us, instead of having a Swoon of the Moon night of once about every 4 weeks, we're going to have it about once every 5. And because we've done enough videos of the first quarter phase moon, we are actually going to go ahead and jump to waxing gibbous come in July. So that's what you can expect in July. But we are wanting to get our waning crescent moon right now, and we hopefully will get a view there. I again do see gaps in the clouds working their way up there. They're going a lot slower than I'd like, however. Anyway, among the things we can actually do is, again, look at this particular view from what it would look like to be here on the ground. So once again, I'm going to pull up Stellarium, and I'm going to make a quick adjustment on one thing real quick so we have a little bit of ease of working with this. Currently, my push-to-talk button interferes with the operation of this program, so give me just a second. Okay, now I've got an alternative key that isn't going to make things difficult for me. Alright, cool. So here we are at Stellarium, and again, if we look up at the moon and zoom into it, we have a nice view of that waxing crescent going on there. However, if we are going to see what other phases look like, we can actually go ahead and advance time in this particular program. And so first quarter is going to come in about 3 days on Sunday, so we can actually just advance time a bit there. And so let's see. Yeah. There we go. There's our first quarter moon. So as we kept the same time frame, very close to sunset and twilight around 8:40, where would we expect to find the moon in the sky at this point? Well, it's going to be close to the meridian, the line that connects the north, directly north to directly south over the sky. And so if we zoom out here, you can see the moon is now in Virgo at this point, and we're getting pretty close to that meridian line, which is going to be, I forget the hotkey for it. There it is. All right, so we're a little bit after what would be truly sunset. This is dusk, so we can actually backtrack time and show right around sunset, which should come close to 7:38 around that time. You see the moon is very close to the meridian. Now, if we want to advance even further into the future, we will get to see a number of other things. Yes, we are in a waxing crescent right now. What I'm doing is advancing time to show how the phases actually shift, because I'm still waiting for the clouds to clear a little bit, and then we'll get a view up there. Okay, just double checking. We're going to get a full moon on the 4th of July. And as we advance time there, you can see the moon jumping ahead. Oops, I'm pressing the wrong button here. Now I'm pushing the right push-to-talk button. That isn't throwing everything off for us. So back on the 4th, we are at a full moon, which means when would we expect the moon to be high in the sky? It's going to be high in the sky actually really close to midnight. So if we advance all the way to midnight, right around here, we actually have the moon very nice and high in the sky. The variance that you'll see, why it's not perfectly there at the meridian at midnight, again, the meridian here, this line that connects south to north, is going to be due to a number of different factors, including what is called the equation of time, the variance between you would see on a sundial versus what you would see on a clock on the wall. Clock on the wall averages things out, but because we don't have a perfectly circular orbit and the axis of the Earth is not perpendicular to that orbit, there is a slight variance of the clock relative to where things actually end up, or where the sun ends up in the sky. And so there are some shifts that happen relative to all of that. And because phases of the moon are all part of the geometry of the sun, earth, moon system, yeah, the exact timing of different phases will also shift on that as well. The other fun thing about this point, looking at this particular moment, is we're getting close to a really neat event that is what is referred to as opposition for both Jupiter and Saturn. Those will be coming in July, where they will be right near this meridian again, right around midnight at a couple of specific dates in July, in mid-July. It will happen about a week apart. One will be around the, I want to say the, I'd have to check, but I believe it's the 13th, but I have to double check, so don't quote me on that. All right, so after a full moon, of course, comes a waning gibbous phase, which will occur immediately following it. It doesn't exactly happen in it's not that it's a dramatic shift. There's a lot of area that is called a waning gibbous phase. It's the entire area between full and a third quarter moon. So if we once again advance our days after that particular point, we see things get further and further. And if we look out at the moon, we see it get a bit less full as things go on. And in fact, as we head closer to that third quarter, we'll notice something, and that is that, we're looking at the ground now. That's not good. Yes, actually, we're looking right towards the, in this drawing, or in this diagram, we actually have the dome for the restroom at the observatory set up. This is actually the sky as viewed from right where I'm sitting right now. So if I was here on July 10th at midnight, the moon would be getting ready to rise off in the east. So when will you actually see a waning gibbous moon and a third quarter moon? Well, you're going to have to stay up pretty late for them because especially for a third quarter moon, you can either stay up really late for it or you could just get up really early. And in fact, towards the end of the year when we're doing these live streams for these phases, we actually do want to get up pretty early for them, so we're going to have a few morning streams. So if you're intrepid enough to be able to get up, good for you. I'm going to be doing it too. If not, of course, these are recorded, so you can catch it a bit later at that point. And of course, after we get to third quarter, which happens a few days after that, there we go. After we get to third quarter, the moon is less than half full, and we end up in a waning crescent phase at that point. On in towards the middle of July, we'll see a bit of that going on, and you will again need to get up pretty early to see it at all, because, well, it won't rise until well after midnight. And that's actually why when if you've been here for any of our stargazing events, we actually tend to avoid the moon, so we get really good dark skies. And so a waning crescent phase on into new moon, and even the early parts of the waxing crescent phase are the times we actually target for our stargazing events. So that way we don't have the moon overwhelming our sky and being really bright and making it harder to see dimmer objects. All right, and then one phase we will not be having a swoon at the moon for is actually the new moon phase, which, well, Again, when are you going to see a new moon? Well, when the sun is high in the sky, and we can't really see much there anyway because we'd be looking at the dark side of the moon, that is, the night side of the moon. Yes, when I say dark side, I don't mean the thing that people can be as mysterious as the song goes. No, that is a little bit of a misnomer, because when we're looking at the moon during a new moon phase, and if I go ahead and pull back up our moon orbit movie here, the new moon again will occur right around the point where the sun is directly behind it. So the far side of the moon is completely lit up at that point, and so it's really a misnomer to refer to the far side of the moon as the dark side of the moon. It is dark in the sense that it hasn't been seen by many human eyes, and for a while it was dark in the sense that no one knew anything about it until spacecraft went out there. But nevertheless, it always had light getting on it. It always had its own daytime for half of the lunar month. So yeah, keep that in mind when we're actually looking at those things. Anyway, other fun things we can actually point out is back over to that moon phase map that is very useful to reference. At this point, again, it's worth understanding how far away the moon is currently, and I always love pointing out the diagram that is embedded in this. There are a bunch of different diagrams. This one here shows the relative orientation of the moon. While we always see the same side of the moon, we don't always see it in the exact same orientation. It shifts around a bit in a process that is referred to as libration. And in this diagram, we have a little blue dot there that is referred to as the sub-Earth point. That is the point on the moon at that particular time. If you were standing there, the Earth would be directly over your head at that place on the moon. Again, this diagram up here is the one we were watching that video of, and it shows with an extra highlight here that little ring that you see all the way around. That is the range of the moon's orbit, and so you can see right now that it is actually a little bit closer than the outer edge of it, meaning it's a little bit closer than its average distance. And this little symbol here is referring to, it's using the symbol of the constellation of Aries, which used to be a point for identifying where the vernal equinox was, the spring equinox for those of us here in the northern hemisphere. And that particular point, it's kept that Aries moniker, but it's actually shifted out of the constellation of Aries. And then the one other really great diagram here is hiding behind the rest of it. It is this set of stuff here, and the line that traces over to the Earth here. That is an actual to-scale drawing of the Earth and the moon and the distance between them, with the numbers here referencing Earth diameters out to the moon. The moon right now is a little bit over 370,000 kilometers away. It's a long ways off at the moment, but it is actually closer than its average point, as shown in the center of that marker there. Now, okay, still waiting for those clouds to part. Just looking real quick to try and see where that gap is. It is deciding to be patient. I'm hoping we'll get a viewpoint here, but even if we don't, we have means to get there in some sense or another. One way to get there is with a wonderful program called SpaceEngine. And in SpaceEngine, what we have here is actually a bit of a view of what's going on right now, and that should be on our current time. This is another similar view to what we had here, and while you can go to different worlds in Stellarium, SpaceEngine has a bit of a fancier way of getting around. We can look around and see quite a bit here. We can also again see that the moon is in Leo with a slightly different way of drawing the constellations there. Now, we can, in this particular program, actually go and take a direct flight out to the moon, which is all kinds of fun, so let's go ahead and do that. All right, flying right on in. There we are. Now, this particular view shows that if you were to approach the moon, yeah, you wouldn't see the stars spread out as you got closer. The stars are so much further away that the moon would just appear to come out of the background and cover up Leo if you're approaching it on this particular vector here. Again, Leo's just poking his lion head out over here with his tail poking out the back end there. But again, with this particular view, we can see some really nice things, including where we actually have some really neat craters I really would love to be pointing out. But the sunlight is actually just starting to fall on the Sea of Tranquility, which is worth flying in and taking a closer look at. Now, the beautiful thing about the Terminator is how it actually gives a lot of extra detail on shadows. Now, the Sea of Tranquility is fairly flat, and so you don't really notice much in the way of details most of the time. However, because the sun is just starting to rise on the Sea of Tranquility, as we fly into it here, we can see a bit more of that detail. You can actually see some ridges and everything going on here. And with regards to the Sea of Tranquility and the seas in general on the moon, the Sea of Tranquility and the others, they're lower lying regions on the moon that actually filled in with lava eons ago because that area of the crust was a little bit thinner and the lava was actually able to breach through and fill it to a nearly flat extent. However, among the other things we got to see at that point are things like the way, as everything cooled down, there are some areas that actually caused a number of cracks and fissures. There were some areas with lava tubes and other things left over in that area that actually are really interesting finds. Let me see if I can find some of those features near our particular viewpoint now. There's one. This particular linear feature is the kind of thing you expect from the lava there contracting and causing it to cause some fissures as this area here contracted away from this area over here. We can actually go ahead and fly on in and get a closer look at all that too. It may not look like much, but this particular feature, again, would be completely missed in our viewpoint on the Earth. We could potentially spot this, in theory, with the telescopes if the clouds will clear up. Still not in a gap there. But if we wait a few hours, we aren't going to end up seeing that, and we can actually simulate that with this program. As the sun rises up here, we can see that the little detail there is very easily missed once the sun is high in the sky. Let's go ahead and get back to the present and see what else we can find. Just back up. Oh boy. Let's not go that fast. Does the moon still have magma? That is an excellent question. Moving a little fast there. Let me slow that down. The moon likely does have still a bit of a layer of magma in it, as well as basically not a solid core. There are detected moonquakes that often occur mostly due to the way sunlight is falling on one part of it because of the lack of an atmosphere for insulation. The actual expansion of sunlight on the surface of the moon actually causes it to expand a bit, and so right around sunrise and sunset on the moon there is a bit of moonquake activity. Nevertheless, there is likely a bit of magma deep inside the moon still, though we would need to actually do a bit more exploring to find out the real current extent of that. Need to adjust my velocity here. I'm going a bit too fast. That's the speed I'm looking for. Alright, now as we fly around this area of the moon, this one feature stood out because it was a nice linear feature, but there are other cracks similar to it. And you can actually see them quite readily if you just look anywhere around here, even off to the right there. Okay, it was behaving a little weird there for some reason. Now, some of these will be faults and fissures that came from the actual expansion, or rather the contraction of the seabed, while others might actually be more of the collapsed lava tubes. The winding ones tend to be more of the collapsed lava tubes, while these big ones, like this one right here, you can see very well that there is a it's basically a center section that sunk down, and that means that there was basically two faults, and as everything expanded, the center section sunk down. There's a lot of that particular type of fault lines visible on the moon. Now, as we're flying around here, let's go ahead and visit somewhere a bit more familiar. Okay, the controls are fighting with me. I don't think they like my button for my push to talk. We'll just have to deal with it because I can only put so many buttons on push to talk. Great. A little bit of a control issue here. It's wanting to just keep backing away rather than going forward. Like that. This happens. Let me wrangle this thing for a second here. While I wrangle that thing, just in case the moon pops up, I'm going to put up the telescope view with the nice, beautiful clouds that are really quite dark in the telescope. We'll see if that opens up while I get this thing taken care of. Just a moment. Alright, I didn't see it pop up there, but I got the controls fixed, so we're back at the moon. Things have gotten a little adjusted I flew away and came back. So we're on target now. And we can actually control properly. There we go. Right beneath us now, we got, of course, the Eagle. LM Eagle is Lunar Module Eagle. That is the Apollo 11 landing site. Always like to visit it, just because you get some good perspective, and especially right now, since it's just about sunrise right there, we can see something that was a little bit before or earlier in the lunar day, as it were, compared to when they would have landed there. As we fly in again as well, you can see another one of those fissures right along south of where we're heading here. And I just crashed into the ground. Alright, just barely sunrise here. And you can see just how flat this area actually is in this view. This terrain model will be from actual data. It's not just sort of surmised based on images that the maker of the program tried to make. No, it'll be based on actual data there. And so let's fly on off over towards the Eagle. Now, one thing to note about this particular view is that the Eagle here will not be as it is now. What this program actually does is it keeps the view of the Eagle as it would have been while the astronauts were there. And as such, the ascent module, the upper portion of the Eagle, is still there. All right, let me see if I can expedite this journey here real quick once we get up on. There it is. So this particular time frame being right near sunrise, again, it's a little bit before when the astronauts would have landed there. They landed when the sun was about 9 degrees up above the horizon, and that was really useful because they were able to watch the shadow of the lander as they were coming in, which really helped them navigate their way down safely and make sure they landed carefully. And so you can thank Armstrong and Buzz for doing that well. I'm not sure how it's reacting now. That's not the way it should be. It decided to tilt us on our side. I don't know why. And the controls are, for some reason, locking into either going forward or backward right now. So it's trying to crash us into the lunar module right now. So yeah, the lunar module itself was a feat of engineering, and a bunch of foil all over it that seems like it really didn't need to just be foil. Well, it was actually largely there for thermal insulation for the stuff inside, and it's actually more Kapton, which is a particular type of material that is really useful for them while they're making that whole system there. If you've heard of Kapton tape, it's a similar structure there. Ooh, do I know how old that crater is? It's a good question. I think I might know which crater might have caught your eye. We'll go ahead and take a look at it in just a second. Okay, so it might do something really bright and flashy while I correct the controls issue again. So give me just a second. Yep, it's doing something that would be very unpleasant to look at, so I'm glad I switched it off for you. Okay, I think we're back in control now. And where we're looking right now, we're looking up here again is the Sea of Tranquility. Down here is Mare Nectaris, the Sea of Nectar. And this crater might have been the one you were seeing. I don't know if it is for sure, but yeah, many of those craters are on the scale of billions of years old. This one is Theophilus crater. Yes, and let's see, that crater is about 110 kilometers across, or about 68.4 miles across. And that particular crater, again, the one I'm talking about is that one down there. And that one is on the order of around 3 to 4 kilometers deep. Again, I would love to show you this through the telescope because it is really one that stands out quite nicely. And right now, especially because of the particular lighting we have there. It also has something really special to it because it is such a large crater. Let's go ahead and fly on in and take a closer look at it. I, for one, always like landing on crater rims, so we're going to do that. Now, this view here can show a number of nice things. In particular, you can see quite readily that there is a bit of a mountain in the center of this crater. And when you have something large enough to impact the moon or another object in this way, the actual impact will dig deep into it and liquefy a lot of material, and that material can really have something a lot like a raindrop or throwing a stone in a pond. You actually have the initial caving in that is done by the object hitting, and then the surface can rebound up. And if the conditions are right, that rebound can actually get frozen in place and make a central peak like this one here. I'm going to do a quick fly around so we get another good view of that particular object in this crater. Tilted a little much there, but you can see quite readily now that big central peak in this particular crater. So if you were to go and hang out on the moon, you would find a lot of features like this that would be really quite interesting to not just explore, but to consider how often we find craters here on the Earth, you would be experiencing a very different type of landscape on the moon, one that is often described as, or referenced as the way Buzz Aldrin described it, as magnificent desolation. It is a stunningly stark yet beautiful place. And when we talk about cratering, it is always worth noticing that the entire field of view here is showing really one big crater, but as you go in, you will find craters of many different sizes, including many that are so small they wouldn't have even been able to be picked up by the data that was used to make this simulation in the first place. Many very small craters exist on the moon. Ah, whereas the crater that we hope to find water at, or rather we have found water at, and we might be sending the next mission. We'll head down there in just a minute. Are there any big impacts in our lifetimes, and was the most recent crater? There are a few small craters that have happened in our lifetimes. They're a little bit hard to spot. I'm not even sure how many of them have names. Let's see. Yeah, and so where have we found water? As Lauren pointed out, it is down at the south pole of the moon. So we can head down there to a very specific crater. I think I got turned around. I think I'm going north, actually. We'll go actually south now. Actually, let's just lock on to the moon real quick. Boop, and zoom out a little bit. Yep, we're nice and flipped over, so let's get ourselves oriented properly. And head to the south. Now I'm going to pause here for a minute because when it comes to water on the surface of the moon, one of the things that is a real problem for that water is a lot of sunlight. With sunlight comes a lot of heat, and that has a tendency to sublimate that ice. And by sublimate, I mean given the setup there, that ice isn't going to liquefy. Given the complete vacuum of space and the temperatures involved, it will go directly from a solid to a gas, and so it will very rapidly dissipate. And so where do we find water ice on the moon? Let's advance time here and see what we find down at the southern pole of the moon. For some reason, is not wanting me to actually rotate with the moon. Give me just a second while I get that to work for us. Hold on while we just set foot down here and try to deal with that rotation. There we go. Okay, now as time accelerates, we can see how the phases of the moon look when you're directly above the South Pole. Now, as we can see here, there's an area of the moon where there are some really nice craters right in this area. These craters have the possibility to have some regions there that are in perpetual darkness. And that perpetual darkness is where you can find some possibility for ice to be able to stay there for hundreds of thousands, if not millions of years. Unfortunately, I'm a little turned around, so I couldn't tell you which of these is Shackleton Crater. Give me just a second, I might be able to identify them. Shackleton Crater is the main one where we are hoping to go look. Alright, apologies for the silence. Wanted to make sure I'm getting to the right place here. Yeah, we should have Shackleton Crater, I believe, is the one we have centered right in here. On the map I'm referencing, I was able to spot this one, these 4 craters here, and this crater hanging out over on the left side here. So Shackleton should be that one that was hanging out right in the center of the image, right there, where there's going to be part of that crater floor that never sees sunlight. Now, hoping I'm in the right spot. Again, when you look at different globes and such, the poles of planets and moons tend to be the poorest rendered ones, and so I might be off by a crater or two, but I believe I found the right one here. Hope that answered your question there. How's the water thought to have gotten there? Well, there are a few possibilities, one of which is actually from comets. Comets actually leave a lot of debris in their wake, and that debris has a tendency to impact things. Most of the shooting stars you'll actually see is cometary debris, which tends to be a lot of volatiles, including a lot of ices. And those cometary debris will also hit the moon, and if they hit the moon in such a way that the spray from the impact is going to settle into a crater like Shackleton, it could freeze there and stay there for an immense period of time. Yeah, now it's possible I'm off a bit. This one might be Shackleton, but again, the map I'm actually referencing is kind of terrible, so I can't really point it out well enough, and my lunar geography is only so good. let's see, there was also a question about the most recent impact. Let me see if I can find one of those good ones. There's a few good candidates. One recent one is one that has left a mark that covers other craters. So we'll go take a look at that once I actually reset a few things here on our virtual moon. I can't seem to win with these controls. They keep like switching to a different mode that doesn't work the way I want it to. So we're going to try and go straight there. I don't know if I can actually go directly to that feature in this, but we'll try. No, we're not looking for Tycho's supernova. All right. One moment, please. All right, thank you for your patience. Well, I got that all squared away. Trying to figure out why certain buttons fight with you. Always a fun thing. Anyway, where I wanted to go was Tycho Crater. It's one that's of a similar size to Theophilus, but it is currently off in the night side of the moon. So we will want to shift ourselves around here a bit. While we're looking around about here, if we advance our time a bit, we might get to see it pretty readily. I think that's probably good. Let me adjust around here a bit. Yeah. Yeah, if you're looking carefully, you might find something that stands out. And that is, if you look down around here, you'll see some radiating lines. Those radiating lines are all pointing their way back to a specific crater. This one right here is Tycho Crater. It's also of a similar size to the one we were just looking at. By similar, I mean this one's around 102 kilometers in diameter, or 63.4 miles. And let's go ahead and fly in and take a closer look at that one. As with Theophilus, Tycho crater does have a nice central peak. And this one is very, very well defined. And in fact, if you've happened to be here for one of our Swoon at the Moon events prior to the current issues with our, well, with the way the world's working, the pandemic, you will actually likely have seen our 3D print of this crater right here. This one is likely a bit younger because of the way all that material is dispersed on top of the other craters there. Though there are likely some younger ones, this one is a bit on the big side there. Alrighty, I'm gonna do one quick thing. I'm gonna step away for a second, let my eyes adjust to see if there's gonna be an opening in the clouds that really there should have been one coming by now, based on what I was seeing. So if they're just hanging out and just constantly materializing right as they should be moving out of the way, I want to make sure we know at this point, so give me just a moment. Alrighty, so I gave my eyes a chance to adjust to actually see the sky right now. As you might imagine, being here able to actually have you see me with all these screens on makes it a little hard to see the sky. And looking up at the sky, there are unfortunately a lot more clouds up there. I can see a tiny bit of light that is probably scattering off the clouds in the general vicinity of the moon. I don't expect at this point, unfortunately, to see the moon coming through. I was a bit optimistic, and these clouds kind of took us a bit by surprise. So unfortunately, we won't be directly seeing the moon tonight, but hope you guys have enjoyed getting a chance to see the moon at least a little bit virtually. We got a lot more things planned on the upcoming months, and we'll swing back around and try for a waxing crescent moon sometime later, possibly this year or so. And we also, again, have a lot of other stuff going on here. So, like, we have a few other different video series we have planned, and we've actually started our summer reading program. So if you would like to be a part of that, or if you have some kids who would like to be a part of that, it's largely being held online, but we do have kits that we are handing out as well. The idea of the formation of the moon. That is a really interesting point, and the way that actually is discussed is that something about the size of Mars might have crashed into the Earth, and earlier on the theory was that it was more of a glancing blow. As of late, the fine-tuning of that theory has it more of a direct impact, and that material scattered around the Earth and then coalesced to form the moon. That is the general idea, yes. And that theory is still a viable one based on the information we have now. Okay, let's go ahead and reset a few things here. What's next for SpaceX? There's a lot of things next for SpaceX. Actually, they're planning on a launch tomorrow. You can catch their live stream. It'll be, I believe, around 1:30, might be a little before then, that they start live streaming. So I'd start checking around 1. Though that one is scheduled for, or was scheduled for today, so it was postponed today. It's a rideshare for Starlink satellites and one of their customers, so it's a Falcon 9 launch, not anything crewed, as in having people on it. But what's also going on tomorrow is actually a spacewalk up on the International Space Station, which will include one of the astronauts who went up on SpaceX's Dragon 2 spacecraft, which so far has been performing very well. The SpaceX Dragon 2 Crew Demo 2 mission is still up there right now. It could go for quite a bit longer, but they will probably bring them back at the latest in August, because they want to get the spacecraft back down to the ground, finish its demo phase, get the information off of it, and analyze the results of that whole flight, so they can actually say, all right, we're good to go for full service, and then get the next mission up, which will take 4 astronauts on the Dragon 2, another Dragon 2 spacecraft. They're working on a whole bunch of other things as well, and so they are among other space launch groups, very interesting to follow. Thank you, Lauren, for getting stuff up on there. Yes, for those of you wondering, our observatory coordinator, Lauren Zuckerberg, has been the one faithfully answering your questions in the chat there. So as we're starting to wrap up, a special thank you to Lauren for addressing things there. And there's that link to that live stream going on tomorrow. Other things going on, again, keep an eye out for things here. We're going to be posting a lot more in the coming weeks. So with that, I'm going to go ahead and say thank you all so much for being here. We really appreciate you being here. We hope you had a wonderful time, even though we weren't able to use the telescopes tonight. We'll get a chance to do that here again very soon. And just because it's a fun way to sign off, let's fly on off very quickly from the moon. And there goes the Earth and the rest of the solar system. And it's always worthwhile to see just how big everything is. We are in a wonderful place here on the Earth, looking out at the universe. The universe is immensely vast, and while we sometimes don't get to directly see it with clouds in our way, there are parts of the universe that are rather cloudy in general, and so we don't always get the best view of all parts of it. But there is so much out there to explore. We just always have to keep our eyes looking up and checking things out. So again, thank you for being with us here tonight while we were able to virtually look out at the universe. We hope you guys join us again in the very near future, and hope you have a wonderful night tonight. Thank you, everyone.